Initially, we perform the univariate of Bitcoin price forecasting. In univariate, the closing price depends only on the previous closing price, and in this we use the Lstm model and predicted the price. For Lstm model, we constructed using of the PyTorch module, and we have defined a training function so that it will be easy for the parameter tuning, and can also initialize few parameters and return the function. In this training function, we not only train the model but also we have plotted the predicted and the real values using the matplotlib, and we also done the ML flow on this univariate. Actually, what this ML flow is regarding the analysis of our models, and in this ML flow we have logged the parameters as well as the metrics of the trained models. So in this, and by performing the different parameters tuning, we constructed various models in this way. This is the univariate series, and this ML flow can be accessed using when we run all this code cell-wise. A folder like ML runs will be created where this notebook is created. So for viewing these ML runs, we can open the command prompt in this directory where the ML runs folder is created and use the command ML flow UI. See, here all the graphs will get plotted. See, actually this is the tabular view of our models. In this, when we change the parameters, these are the metrics we're reflecting. In it will be get plotted, and not only this, these models can be saved in our ML flow UI, where we have saved our model, only this model, which is the best model of all our train, as the optimized model. See, in this way, we can save this model. Which is our model. This is the model. We can add its name and some other values also to it. And many charts are also will get created automatically on this MS Flow dashboard, like comparing the this it's comparing mean absolute error, R2 score, root mean square error, and not only this kind of plots, some other plots also gets created. Like we can create a scatter chart, axis y axis, some epochs. We can create a scatter chart, or we can also create a counter chart like mean absolute error change to, and based on the learning rate we can counter chart. In this way we can analyze all our models. This is the ML flow, and next we use the multivariate. In this multivariate, using of different things like opening price, closing price, and not opening price, closing price, high, low, and adjusted close, we predicted the closing price. Coming to this, what we did, we mapped initially with the all these things to the all these 15 days things of all these with the closing price of the next day. And in for this model, I have constructed using of the TensorFlow. In this TensorFlow, I added an LSTM layer of 64 size, and then followed by LSTM layer of 32. Then I have added a dropout of 0.2 frequencies, so which can reduce the overfitting of the model. Well, and we added a dense so that the output is reflected. Then we trained our model using, and after training the model, this is the training and the validation loss of model, and we got these are the results which we obtained. And as when we compare with this, the best model of the univariate, the best model is getting a mean slew error of 13.1, whereas this model is getting only 0.059, which is very much decreased when compared to that of univariate. And this is our project which we worked on. Thank you.